So today we can learn about a topic infiltration. I have already explained about infiltration when I taught you the hydrologic cycle. Okay, so infiltration means the process by which water enters the surface strata. The process by which water enters the surface strata and penetrates downward or moves downward to join with the groundwater. The process by which water enters the surface strata and moves downward or penetrates downward to join with the groundwater. That particular phenomenon is known as infiltration. And the rate at which water actually infiltrates through the soil. The rate at which water actually infiltrates through the soil at a given time. The rate at which the water actually infiltrates or penetrates or percolates through a soil at a given time is called infiltration rate. And the maximum rate at which the soil in any condition, the maximum rate at which the soil in any condition is capable of absorbing water. The maximum rate at which the soil in any condition is capable of absorbing water is called infiltration capacity. The process by which water enters the surface strata and percolates downward to join the groundwater is termed as infiltration. The rate at which the water actually percolates through the soil at a given time is known as infiltration rate. The maximum rate at which soil in any condition is capable of absorbing this water, is capable of absorbing the water is termed as infiltration capacity of soil. So you assume initially the soil is dry. Okay, you assume that initially the soil dry ആണ് assume ചെയ്യുക. And a rainfall occurs. Initially, the soil is dry and a rainfall occurs. So, what happens? The infiltration rate will be higher. The infiltration rate will be higher because that soil is dry. Okay. Initially, you assume that the soil is dry. Soil dry ആണ് അപ്പോൾ ഒരു rainfall ഉണ്ടായി എന്ന് assume ചെയ്യുക. Soil is dry and a rainfall occurs. So what happens? The infiltration rate will be very high. But as rain continues, you assume that the rain is continuing. You assume the rain is continuing. But as rain continues, the capacity of the soil, rain continues ചെയ്യുകയാണെങ്കിൽ the capacity of soil to absorb more water, the capacity of soil to absorb water decreases. Soil dry ആയിരിക്കുമ്പോൾ maximum water absorb ചെയ്യും. But when the soil becomes wet, the capacity of soil to absorb water decreases. Soil dry ആയിരുന്നപ്പോൾ the capacity, infiltration capacity was more. But as soil becomes wet, the capacity of soil to absorb more water reduces. So we can say the infiltration capacity is reducing. Initially, when the soil was dry, the infiltration capacity was more, but after that the soil get wet, therefore its infiltration capacity reduces. Therefore, if we are plotting a graph between infiltration rate and time, it will be a falling graph. So, infiltration rate soil dry ആയിരുന്നപ്പോൾ കൂടുതലായിരുന്നു, പക്ഷെ വീണ്ടും soil wet ആയി കഴിയുമ്പോൾ ഇൻഫിൽട്രേഷൻ റേറ്റ് കുറയും. അതുകൊണ്ട് ഇൻഫിൽട്രേഷൻ റേറ്റും ടൈമും കൂടെ ഒരു ഗ്രാഫ് പ്ലോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഇറ്റ് വിൽ ബി എ ഫോളിംഗ് ഗ്രാഫ്. ഇഫ് യു പ്ലോട്ട് ഇൻഫിൽട്രേഷൻ റേറ്റ് അഗെയിൻസ്റ്റ് ടൈം, എ ഫോളിംഗ് കർവ് വിൽ ബി ഒബ്റ്റെയിൻഡ്. And this particular curve is known as Horton's infiltration capacity curve. This falling curve is known as Horton's infiltration capacity curve. And he derived a relation Fp is equal to Fc plus F0 minus Fc into e raised to minus kt. Here you can see a relation Fp is equal to Fc plus F0 minus Fc into e raised to minus kt, where Fp means it is the infiltration capacity in mm per hour at any time t. At any time t, infiltration capacity at any time t is assumed as Fp. You can see the infiltration rate is in mm per hour and time you can see it is in hours. So Fp means it is the infiltration capacity in mm per hour at any time t. Then you can see F0. What will be F0? It is at the beginning stage. So F0 means it is the infiltration capacity. It is at the initial stage. That is the initial infiltration capacity. That is F0. And Fc is the constant infiltration capacity. That is, you can see, at first I told you the infiltration is more, then it reduces, and finally it reaches a constant value. Initially, when the soil was dry, the infiltration capacity was more, and after that the soil becomes wet. So what happens? The curve falls, and finally it reaches a constant value, and the infiltration rate corresponding to that is known as Fc. Horton derived an equation Fp is equal to Fc plus F0 minus Fc into e raised to minus kt, where Fp means it is the infiltration capacity at any time t. Fc means it is the constant infiltration capacity. Fc is the constant infiltration capacity. You can see it is constant during that time. And F0 is the initial infiltration capacity. F0 is the initial infiltration capacity. T means it is the time in hours from the beginning of rainfall. T means it is a time in hours from the beginning of rainfall. And K is an empirical constant. Here you can see a constant K. K means it is an empirical constant. And this particular curve is known as Horton's infiltration capacity curve. Next is measurement of infiltration. For measuring infiltration, we depend on two devices. One is double ring infiltrometer and the second one is tube type infiltrometer. One is double ring infiltrometer and the second one is tube type infiltrometer. So first we can see the ring type infiltrometer. There is a double ring infiltrometer or the ring type infiltrometer. There are two types. One is ring type, that is double ring infiltrometer because they are using double rings. And second one is tube type infiltrometer. First you can see the double ring infiltrometer. In the double ring infiltrometer you can see concentric rings. This is the sketch, but I shall show the photograph. This you can see concentric rings. You can see one ring and the second ring. You can see two rings here, one ring and the second ring. The rings are placed with their lower edges a few centimeter below ground and upper portion projecting above ground surface. കുറച്ച് portion ground surface നെ മീതെ പ്രൊജക്റ്റ് ചെയ്ത് നിൽക്കും, but lower edges are inside the ground. Lower edges are inside the ground, but the upper portion projects above the ground surface. You can see upper portion, idana ground surface, ground level. So you can see the upper portion, their portions are projecting above the ground surface. Okay. Next, water is applied in the inner ring as well as in the annular space between inner and outer ring. ഈ ഇന്നർ റിംഗിലും വാട്ടർ കൊടുക്കും. സിമിലർലി ദ സ്പേസ് ബിറ്റ്വീൻ ഇന്നർ റിംഗിലും വാട്ടർ അപ്ലൈ ചെയ്യും. Water is applied in the inner ring as well as in the annular space between inner and outer rings. Water is given in the inner ring as well as in the annular space between inner and outer ring. As you can see, water is applied in this inner ring and also between the and also in this annular space between inner and outer ring. Inner ringilum water ne apply cheyum. Similarly, in the annular space between inner ring and outer ring also the water is applied. Then the water which must be added to maintain a constant level, it gives the infiltration rate. Okay, the water which must be added to maintain a constant level gives the infiltration rate. That is, suppose you fix here a level. ആദ്യം ഒരു ലെവൽ ഫിക്സ് ചെയ്യുക. എന്നിട്ട് വാട്ടർ ഇന്നർ റിംഗിലും ആനുലാർ സ്പേസിലും അപ്ലൈ ചെയ്യുക. First you fix a level, then you apply water in the annular space as well as in the inner ring. ഒരു ലെവൽ ഫിക്സ് ചെയ്യുക. ലെവൽ ഫിക്സ് ചെയ്തിട്ട് വാട്ടറിനെ ഇന്നർ റിംഗിലും ആനുലാർ സ്പേസ് ബിറ്റ്വീൻ ദ ഇന്നർ റിംഗ്, ദാറ്റ് മീൻസ് ദ സ്പേസ് ബിറ്റ്വീൻ ദി ഇന്നർ ആൻഡ് ഔട്ടർ റിംഗ്, apply the water inside this inner ring as well as in the annular space between inner and outer ring. First you fix a level, then you add water to the inner ring and also in the space between inner and outer rings. Inner and outer rings തമ്മിലുള്ള സ്പേസിലും inner ringിലും water apply ചെയ്യുക. So the water which must be added to maintain a constant level. Water which must be added to maintain a constant level gives the infiltration. So first നിങ്ങൾ ഒരു ലെവൽ ഫിക്സ് ചെയ്തത് H1 ആണ്. നിങ്ങൾക്ക് രണ്ടാമത് കിട്ടുന്ന ലെവൽ H2 ആണെങ്കിൽ H2 മൈനസ് H1 gives the infiltration rate. ഫസ്റ്റ് നിങ്ങൾ ഫിക്സ് ചെയ്ത ലെവൽ H1 ആണ്. Then the level you are obtaining is H2. Then H2 minus H1 gives the infiltration capacity of that soil. First you fix a level, then you apply water inside the inner ring and in the annular space between inner ring and outer ring. Then the water which must be added to maintain a constant level. The water which must be added to maintain a constant level gives the infiltration capacity of the soil. And the function of the outer ring. The function of the outer ring is to prevent spreading of water. The function of the outer ring is to prevent the spreading of water. That is about the ring type infiltrometer. Next we can talk about the tube type infiltrometer. Tube type infiltrometer. A tube type infiltrometer consists of a single tube which is having a diameter of 30 centimeter. It consists of a single tube having a diameter of 30 centimeter and a depth equal to the penetration. That is, it is having a longer depth so that spreading of water do not occur. It is having a greater depth so that spreading of water do not occur. You can see that the spreading of water do not occur in the single tube infiltrometer. In the tube type infiltrometer or in single tube infiltrometer, spreading of water do not occur. Here also we fix a particular level and the amount of water that must be added to maintain a constant level. ആദ്യം H1 എന്ന് പറയുന്ന ഒരു ലെവൽ ഫിക്സ് ചെയ്തെന്ന് അസ്യൂം ചെയ്യുക. Then the water which must be added to maintain a constant level gives the infiltration rate. So constant level പിന്നെ കിട്ടുന്നത് H2 ആണെങ്കിൽ H2 minus H1 gives the infiltration capacity of the soil. That is about tube type infiltrometer. So this is a ring type infiltrometer, a double ring infiltrometer. Okay, ring type infiltrometer double ring infiltrometer another. For the exam you have to draw this sketch itself, and for more explanation you can depend on the photograph. Photography നായിരിക്കും നിങ്ങൾക്ക് കൂടുതൽ explanation കിട്ടുക, but for the exam you should draw this figure. Then the cross sectional area of a double ring infiltrometer will be like this. And the sketch of a tube type infiltrometer or a single tube infiltrometer will be like this. So in both cases, first we are fixing a level, and the water which must be added to maintain a constant level gives the infiltration rate. So if the first level is H1 and second level is H2, by finding the difference we can know that H2 minus H1 is the infiltration capacity of the soil. That is about infiltration. Okay, thank you.